This diagram is what we call a proof without words. In this case, a proof of the fact that the sum of the first n odd numbers is a square. For example, this is 1, 1 plus 3 is 4 is a square, 1 plus 3 plus 5 is a square, 1 plus 3 plus 5 plus 7, it's a square. So how can we make this into a proof? Alternatively, you can interpret this diagram as the fact that the difference of squares, of consecutive squares, is an odd number. And in fact, those differences go through all the odd numbers. So when you add up all the odd numbers, you get a square. Algebraically, you could express the fact that the difference of consecutive squares is an odd number as n squared minus n minus 1 squared. That's 2n minus 1, which is an odd number. And in fact, this expression can represent every odd number. So every odd number is a difference of consecutive squares. Now we can prove the fact that the sum of the first n odd numbers is a square using induction. The first case of n equals 1, that is trivial. 1 is 1 squared, so that works. Now for the induction step, let's prove that the case of n minus 1 implies the case of n. So we suppose the case of n minus 1, so the sum of the first n minus 1 odd numbers is a square. And then if I add to this part of the quantity the next odd number, then this is by assumption n minus 1 squared. That's the n odd number. And by the equation we came up with before, this adds up to be the next square. Therefore, by the principle of mathematical induction, we are done. And it's true for all n.